CCNA security. In the world of computer networking, there's an ongoing struggle between administrators trying to protect their networks and hackers trying to gain entry. It's my belief that a CCNA should be aware of the basic security measures in a Cisco device. In this nugget, we are going to start by defining and outlining password recommendations on a router. We will also take a look at secure network management techniques. Then we'll take a look at the banner and see how it should be used in a Cisco router. We will follow this with a look at how to secure 3 connectivity methods into a router. And those methods are the VTY connection, the console connections, and an HTTP server. After that, we will demonstrate a simple anti-spoofing design, and then we're going to eliminate fluff in our routers. And the last thing we're going to talk about is the PCERT, what it is and how you can best use it. The most important aspect of any security model is the proper processing and handling of passwords. So let me get you familiar with the passwords again within an iOS device. We have 2 levels. The user exec is the level you first get into in an iOS device, and then you use the enable command to take you up to the privilege exec level. Now, each of these levels optionally can carry a password. Let's make it to where it's not optional in our design. The first recommendation is always have a password on both levels. The next recommendation I'll make, and it is equally important, is that these 2 passwords be different. Don't make them the same password. Remember that by design, Cisco has 2 different levels so that we can save ourselves from ourselves. In other words, people that we want to grant access just to use show commands exist here, and the few people that we want to allow configuration parameters within the router or the switch exist here. If the password is the same, then we really don't have any distinction between the levels. Once you've taken both of these measures, you need to be aware that within the configuration file in an iOS device, both of these passwords are going to appear in clear text. In other words, no encryption at all. So if these configuration files get out of your control, people are going to know your passwords. Sounds pretty dangerous, and it is. So what you need to do is you need to take a precaution so that that doesn't happen. Not so that you don't lose your configuration file, because you know what? That will probably happen. That will be compromised because there are so many people involved in network administration today that somebody's going to leave it out or give it to the wrong people, something of that effect. So here's how we save ourselves. There's a command, service password-encryption, and what it's going to do is within our configuration files, it's going to encrypt the user exec passwords and also the privilege exec passwords. Remember, on the privilege exec, the password we're talking about initially is the enable password. And that's how you set it too, enable space password, and then you give the password string. Let's jump into our router and demonstrate what we've talked about so far. All right, the router is waiting for the password. This is the user exec password as we talked about above. Then I hit the enable command, and I provide a password for access into the privilege exec mode. So I did the same. What I'm going to do now is show you the configuration file. That way we can go over each of the passwords individually. Let me blow this up a bit. All right, the first thing we see in our configuration file as far as passwords is the enable password, and it defines it here as Cisco. Remember I said this is going to be in clear text. This is not encrypted at all. So if you're sharing configuration files, somewhat dangerous. All right, let's continue with our configuration. And what we're going to find is within the line configuration for line console 0 and line VTYs 0 through 4, the 5 VTYs, we will have password information there. Now this is the password to get into the user exec level. So I have password Cisco on both instances. So we have a problem here. One of the recommendations was to make sure that the 2 levels of passwords were different. Otherwise, you negate the purpose of having 2 levels within our router. So let's make the changes there. We're going to go into configuration mode via terminal, and I'm going to change the enable password. So enable password 0 so that it knows what's going to follow is in clear text and is the password. And we had it at Cisco before, so now I'm going to change that to San Fran. Hit enter. Let's Control Z to get out of the configuration mode, and you can tell that by the change of the prompt. And now what I'm going to do is I'm going to disable to go back. Sorry, disable. Command has to be fully functional. Then I'm going to type enable, and now it asks me for a new password. First I'm going to provide Cisco as I did before. Notice that doesn't work. Now San Fran, and we're in there. So you note that the changes to the passwords take effect immediately. Now if for some reason you had a problem with that password and as you typed it in, you must have fat fingered something because nothing's getting you into the proper level, in this case up to the privilege mode. Then what you can do is simply reboot the router, because you can tell so far we haven't copied the running config to the startup config. We talked about that earlier in the nugget about the two configuration files. One is temporary and one is permanent. Right now, these changes only exist in temporary memory. So now that we have those changes made and we want to keep them, let's copy them into the permanent memory by hitting copy, run, and then get into start. So now we have a password on both levels, and we have the passwords being different on both levels. What we don't have is a matter of having the passwords encrypted. They're in clear text in our configuration file. So let's show it again, show conf. First thing we're going to see is our change that was made, San Fran here. As I page through this, Cisco here. So the command that we need in configuration mode, configuration T here, is going to be the service password encryption command. Let me type that in, service password dash encryption. All right, just hit enter there. Control Z out of this. Remember that this is only effective so far in the NVRAM, which means that we have to do a show run to see the changes. If we issue the show configuration at this point, that's showing us what's in permanent memory. So show run. Let me blow this up so I can see exactly what our output's going to be. And here we go. Here's the start of my command, show run. And the password now shows 7 instead of 0 because what follows is encrypted. So obviously that doesn't look like San Fran and will be a bit difficult to extract San Fran from that. Let me page to do this to get to the end, and we'll get to our line configuration mode. And here we have our passwords again with the 7, and this is code for Cisco. So it seems at this point that all is well. We have our passwords different between the two levels, and we also have the service password encryption in effect so that in our configuration files, the passwords appear as gibberish rather than the actual password. Don't feel too comfortable though, and this is why. Service password encryption was set by Cisco quite a while ago, and now what they're doing, and even at the time that they set it up, they're saying that it was never designed to stand against a serious decryption attempt. In other words, this is just facing, if you will, so that it's not as easy. But this is not going to thwart a serious attacker. And so what Cisco says is if you have a configuration file that is set with this weak encryption, which is service password encryption, treat it exactly as you would if you had those passwords in clear text. All right, so pretty severe. I feel better with that put on there, but there is another measure that we can put into effect. So far we've talked about the enable password for our second level of password. Well, there is another, and it's the enable secret. We talked about it earlier as we discussed passwords. So if you recall, the enable secret is stronger than this service password encryption that you're going to see in the file. And the reason for that is that the enable secret uses a message digest 5. All you really need to know about that is it is a strong encryption. All right, so we consider this weak and this strong. And because of that, if we set the enable secret password, it's going to appear in our configuration files encrypted. So again, that gibberish is IE 5, 9, whatever else will follow. The difference is this is not going to be changed easily. In fact, there's some strong verbiage in the community that says it won't be decrypted at all. So let's get into our router and set the enable secret password. All right, the first thing I've got to do is get into configuration mode. And then I'm going to type in enable space secret. Hit enter at this point because I wanted to show you again just to refresh the memory. If I hit 0, it tells me that an unencrypted password will follow. So that's what we're going to opt for, 0. And then we're going to set our password. In this case, we're going to set it to secret. Hit enter. Keep in mind, and we illustrated this in the password nugget as well, that the enable secret password should not be the same as the enable password. And you know, the truth is, if you have an enable secret password, as soon as that takes effect, it's going to negate the enable password. In other words, the enable password isn't usable. So my recommendation is don't even have an enable password set. Take it out of your configuration so it doesn't give them a hint as to what may be set on the enable secret. In other words, if you have enable password San Fran, it might give them a hint as to the fact that the enable secret might be Cisco or something related to San Fran or Chinatown, something of that sort. So my recommendation here is to type in no enable password And remember, we set it 0 to San Fran. So we're going to take that off, hit that. Now Control Z, let's show our running config. And what we're going to see here is that the enable password, starting right here, we got our show run. The enable password is gone, and the enable secret is completely encrypted. And it is a much more, and a much stronger, if you will, encryption than we had with the password encryption service. So at this point, you're probably feeling pretty confident with the enable secret, but then you're hanging on to the fact that I said this is a weak encryption, and I still have my user exec password encrypted with this weak encryption. So more than likely, if a configuration file gets into the wrong hands, they're going to encrypt this password and at least have the first level of entry into my router. So how do we stop that? Well, this is the thing. The way configuration files get into the wrong hands is either we send a software copy to an individual that doesn't control it correctly, or we have paper copies that get out of control or get out of our office, things of that sort. So this is my recommendation. Anytime you're going to share a configuration file, either via software or store a hardware copy, use this command, and it's show text support. It's going to give you a lot of other output, but at the same time, it's going to give you a configuration file with the passwords already removed. So let me show you. Show text dash support. And then we're going to have to go through quite a bit of information until we get here. Let it run through completely. When it's done, we're going to scroll back up. But you did see an indication that it was showing the running config. And what I'm going to show you there is the fact that each of the passwords are listed in the configuration as they normally would. It's just where the password would appear, it simply says removed. And that's what you want so that you can copy that configuration file onto a notepad. And then, like I said, software copy you can share with people, or hardware copy to store in your files can be shared as well. All right, so let's go back up here to our running configuration file. And there you have it. Starting here, configuration file, version 12.0. You've got your enable secret, passwords removed. Let's go down to the lines where our exec passwords for user level are at, and you see here that they're both removed as well. So what you would do is just copy and paste this onto some other document, and that's what you would use to share. Pretty awesome, isn't it? All right, but we're not completely done with passwords as of yet, because our conversation on the network management security process is going to focus on SNMP, which is a simple network management protocol, and what it uses as pseudo passwords. In other words, it's community strings. Community strings are going to be set within this type of protocol, and simply it's a password that's shared between a network management device, and it's usually a large server, and then the local devices that you have out there. It can include a router, or it can be devices like N1, N2, host on a computer, for a PC. These devices are going to be polled by that server, and information is going to be garnered from them, like how many octets have been transferred in, how many octets out, error counts, things of that sort. Well, within this SNMP, for this server to have access into those devices, it has to provide a password. Now, this isn't something that you're going to type in. This happens behind the scenes within the protocol. And that's probably what makes it a little bit more dangerous, is the fact that you're not actually controlling this password exchange that they call community strings. Now, there are two levels. The first level is going to be for a read-only, and then the second level has to do with read and write privileges, which obviously was more dangerous. So, simply, this kind of mirrors our router levels, right? The read-only is the show commands, and then the read-write is the show commands. Also, you can configure now, so this server can write or change configuration on these devices. Let me take a step back here and make sure I didn't cause any confusion. When I said that you're not going to type in these community strings, I mean that you're not going to actively type them in as you would with a telnet session. If this server was trying to telnet to a device like the router, you would type in telnet and then the IP address, and then be prompted for a password before communication passes between the two devices. All right. What I'm saying is you will set this community string within the server, so you will pick it and you will write it into the configuration file, but it will not be written by you every time information needs to be exchanged. That's what happens in the background. As far as Cisco devices are concerned, SNMP comes in two versions, version 1 and version 2, that can be applied. All right, let's start with the problems in version 1. The first is the fact that these community strings are passed behind the scenes. We've talked about that already. And the second is when these community strings are sent, they are sent in clear text. That means that whatever you assigned that community T string to be, it's going to be seen over this wire. So where's the danger in that? The danger comes in when somebody has a sniffer on the wire. In other words, a protocol analyzer that is simply going to sit on this wire, and it's going to collect all information that's transferred in either direction on the cable. And when it does that, it's going to collect these packets for SNMP, and part of that is going to contain a clear text password. So from that point forward, this individual who is doing the sniffing on the wire now has a password, the community strings, so they can gain access into your devices. Now, if it's simply the read password, it's not as dangerous, although you don't want somebody else collecting this information. And if it's a read-write string, then you're in for a world of hurt. I mean, to give you an example, with read-write capability, you can go into a router and you can change interface parameters, causing them to completely go down, okay? All right, so the next problem we have with version 1 is that it comes with default community strings. The default strings are public for the read and private for the read-write string. Now the problem with this is, if somebody were to set up a network management station within your network without you knowing, and they try to use these default strings, and you've left your devices set to those default strings, they are automatically going to collect information and be able to write configurations onto those devices. So never do that. These must always be changed to something that you keep private within your corporation. Now version 2 is not going to help you with the fact that these default settings for the community strings are set up, because those are set up on your devices out here. But what it is going to help you in, and this is a great help, is it's going to change this fact here. Okay, so the community strings, as they're transferred between devices, are no longer in clear text. In version 2, they're going to be encrypted. That is very, very well worth the change or the upgrade up to version 2. Now, the other thing that you can understand here with version 2 is that it's going to allow filtering capability for some of the data. So, you know, similar to Access List, if you will, it's going to say that if you want a portion of my data here, then you have to be a certain IP address. This functionality is valuable as well. So far in this nugget, we started out by talking about password management. Then we looked at network management concerns as far as security. Now we're going to go into the login banner, and then also we're going to study some of the connectivity methods into your devices. The login banner itself is what's going to come up whenever you access the device. Now, let's drop a router here. Remember from our previous nuggets that we have many ways of accessing this device. One can be a console connection, which is a connection, a cable directly between the router and some PC. Another is a VTY connection, which is a connection over the local area network. So the router is connected to a local area network. That local area network has some PC on it. This PC can use Telnet, SSH, some protocol like that to come across that LAN and connect on an interface, an Ether interface or a serial interface if this were a WAN. Each of these connectivity methods result in you gaining access into the iOS, which is the operating system within a Cisco device. Now, normally what you would get is a password prompt so you can get into the user exec mode. We want to change that. We want to set a banner, and the command here, banner space login, and then provide the line or the information we want within the banner is going to be used to do that. We want to set a banner that comes up and will give you some verbiage before you're even prompted for the password. You've got to understand the main use for a banner. What it really is to establish legal ground to support your prosecution of somebody that has entered your system without permission, all right? So what you want to do is have something in this banner that legally will stand up to say you gave proper notification to an individual that you should not be in my system, and that individual accessed your system anyway. All right, so this is the thing. In different jurisdictions, there are different rules. So I can't give you a hard and fast rule set of what should be placed inside your banner. What I can say is you should probably seek legal counsel within your area so that you can put the exact verbiage needed in there to help you if you ever do have to prosecute somebody that has been in your devices. But I can give you some general rules, and those are: don't put information in there that points to the router type or the location, you know, that you're in, or even the company that this router or even a switch is being used for, okay? This information should be kept private. Although in itself, it can't be hacked, in other words, it's not valuable information, this information can lead to an attempt or to a hack being successful into your devices simply by giving them hints and clues as to how to proceed next. Let's get into the router now so I can show you how you would set this banner up. First thing we have to do is get into configuration via terminal, and then we can start typing BANNER for banner. Login is the type of banner that we're going to put in, and at this point you have to have delimiting characters. In other words, some character that is going to be used to signify I'm about to start typing in the text I want to appear, and at the end that same character being used saying I'm done typing in this text. So what I'm going to use here is I'm going to use C space and then just type in this is the login, in banner. Exclamation point, space, and then again my character delimiting the end of my text. Once you do that, you hit enter. All right, what we want to do now is Control Z out of the configuration mode, and we're going to exit this router completely. All right, now as we try to gain entry, I'm going to hit enter here. And before it asks me for my password, note here, it gives me the information that I sent within that banner. This is the login banner. This is where your information would appear. Let me gain access into the router by typing the right password, and there you have it. Now that our banner is set, let's look at the security recommendations for each of the connectivity options. First, we're going to start with the virtual terminals. Remember, this is where I would access via some type of protocol like Telnet or SSH. The first thing we're going to look at is how to limit those specific protocols, and we do that with the transport input command. All right, so let's try this out. Let's say that I have N1 in existence out here, some PC or a server, and a router here. Local area network in between. We're telling this device with this command what we can accept for a VTY connection. If we say that it's just Telnet, then that's all that's going to be accepted. If we say it's just SSH, which is secure shell, you can think of it as an encrypted form of the Telnet, does the same thing, but it's more secure, then we would limit it just to that. Or we can opt for both of the capabilities, transport input Telnet space SSH. Let's get into our router so I can show you that command in action. The first thing I'm going to have to do is get into the configuration mode via terminal, and then I'm going to get into the specific lines that we want to make the changes to. So line VTY 0 through 4. And now we can type in transport, input, and then I'm going to hit question mark so you can see the options. Transport import. We can allow all protocols. We can allow no protocols. This essentially will shut down the access into the VTY or our login, Telnet. We would have the SSH option here if it was provided on this specific iOS. So keep that in mind. SSH is only provided on certain iOSs, not all, but Telnet is. So in this case, we're going to allow the Telnet protocol to be used for the transport input. So what this means is, back to our diagram, if somebody is out on the local area network trying to access this router through a VTY and they do it with any other protocol within Telnet, they will not succeed. Now that we've blocked the protocol, we want to further secure this environment by setting up an IP access class on this interface. And what that means is, remember, the IP access class is the command that's used to apply an access control list, or an ACL. Now what we can do is set up our ACL to where only certain IPs are allowed access. Let's say in this case that we had an IP of 192.168.1.254. Within our access list, we could permit that IP address, and it'd be the only one, and then we would deny anybody else entry, and we'd apply it to the line VTYs with the IP access -class command. Once that is completed, any other device that tries to come in, let's say N2 with a different IP address, is going to be blocked as far as access. All right, to further secure this, let's talk about the passwords. Remember that we want this password to be different than the enable password or the enable secret. Just, to stay ahead of the hackers, at least one step. And you would set a password specifically in this area, and it would be password is the command, and then you would opt for 0, letting it know that the next command is going to be a clear text password, and then whatever your password may be. All right, and the last step to secure the VTY would be a session timeout. And this is how long in seconds a session can be open without any input coming from the source into that router. So in other words, if you had the session timeout set to 10, if for 10 seconds there was no activity coming from N1 into the router and you'd already established a session here, it will time out and be disconnected at the end of that 10 seconds. The concerns for console connectivity are a little bit different. What you're going to note is that a console connection is going to be set, as before, N1, into a specific device via a cable. So there is really no need for a transport input command because you're not going to access via Telnet, RLogin, SSH, anything of that sort. This is a serial connection between the devices, okay? But you do have password concerns, and this is the main concern that you have with the console, and a big recommendation. When you're setting the password for your console, make it different than the enable and enable secret. We talked about that already. That's used at the privilege mode. But what I'm going to say is make it different even than you would for your line VTY access. And this is why. Some people may be allowed through your local area network to come into your devices, right, and have that permission. You don't want to allow that same permission in through your console port. Why is that? Remember our nugget on password recovery. The process for password recovery wasn't that difficult. It had to do with a break sequence, setting of the register, and then we were in at a level that passwords did not apply and we could change them around. You don't want this to happen, obviously, in the wrong hands. So, with that true, if somebody knows the access or the password needed to connect via VTY, you don't want them to be able to grab a computer, go into the wiring closet, connect into your router with that computer, and have access to the console because of this password recovery technique. You can't do this via VTY, so it's not as dangerous, right? Let's jump into our trusty router so we can see this in effect. The first thing I'm going to do is issue the command for show configuration. The reason we're doing that is so I can show you that the passwords on both of these lines, line con 0, password is Cisco, and line VTY 0, password is Cisco, are the same. Now what we want to do is make them different, obviously. So conf T, I'm going to get into line console 0, and then I'm going to set password 0, and what I'm going to do is set it as DIFF for different, so that it's a different password. Control Z. Now I'm going to show you the run, again, because we haven't saved this configuration into NVRAM as of yet. And at the end of this show run command, we're going to see that we have different passwords now. Line console 0 is set to diff, and then line VTY is set to Cisco. The last connectivity method that we're going to cover is a new one. In other words, we don't have another nugget that talks about HTTP server. The reason I include it in this section is in case you have to use it. And the reason I don't include it in an individual series is, one, it's beyond the scope of the CCNA, and two, it just doesn't work that well. I mean, to be honest, trying to go through this interface within the HTTP server isn't that great of an idea. Let me explain what it is, the idea behind it. I can have N1 here, and again, I'll have my local area network as I did when I was making my VTY connections, and this is simply allowing a connection to come into your router via HTTP. Okay, and this normally operates at port 80 when we're talking about our TCP ports. And so it's just going to allow this connection, then you're going to have a web page with configuration information in it for your router. It's not set up as clean as the CLI is. I mean, that's the bottom line, and that's why it gives some people some trouble. This ability to connect via HTTP is not on your devices by default. There's a command you need, and it's the IP HTTP server command to start this process rolling. Again, if you don't need this functionality, do not activate this. I'm really just supplying this in case you have to have that functionality. I'm going to give you the best ways to secure it. Once we have it on, we're able to set the IP HTTP port here. Now, as I said here, the normal web page port or HTTP port is 80. So if I'm going from N1 through my local area network to a www server, this server is listening on port 80 for connections. Okay, that's the default port for this type of service. What you can do in the Cisco world to secure this a little bit better is you can say, I want to use a different port, and it can be any port between 0 and 65,535. So you have 65,536 choices to make here. And keep in mind you have the well-known ports that you don't want to get in the way of if you have those services running already, but you can set this to some other port. In fact, if you're using it, I would make that recommendation. So let's say, for example, you set this to port 3000. Then you also have to have the ability to set this device to send out HTTP type of connections with a destination port of 3000 so that it can connect to your router. So that gives you a bit more security. The next thing we can do with our access class command, we can use an access control list to limit who can make this connectivity. Obviously, we would do that by IP address. So if we just had one device that we wanted to connect via HTTP into our router, we would simply put that one device in an ACL under a permit statement and then deny anybody else that tries to come in. So between these two, it makes it a bit more secure. But again, I don't think the payoff would be worth it, but it's up to you. All these commands are global commands and apply to the router at a global level. So let's get into configuration via terminal, and I'm going to type in IP HTTP, and instead of finishing the first command, I'm going to hit question mark here because it's going to show us all the commands we're going to use. First of all, server. This is going to enable the process to connect via HTTP. Then we have a port. Again, we can change the port that we use to connect, and then the access class used to apply an access control list. So at this point, I'm going to type in server, move my cursor here, space, question mark. You can see that's the end of your command once you set that up. So I can do that there. Now if I type in IP HTTP port, hit enter, it's going to show you the range of the ports that you can use. Again, 0 to 65,535. And then obviously we can apply an access class into this interface. That wraps up the section of securing our connectivity options into our device for the login banner, the VTY, the console, and the HTTP server. Now we're going to look at anti-spoofing, then removing fluff from our router, and finally the pcert. As far as anti-spoofing, what we're really talking about there is the ability to make sure that the router doesn't get confused about who's on each side or who's out of each interface here. Before we talk about how to set this up, let's talk about why. There are some well-known hacks out there that are going to be employed by trying to have a device pretend like it's a device that you trust. So let's say that there's a hacker device out here, and N1 exists on this side of the network. N1 is 192.168.1.254. All right, your router is set up to trust .254 to access, let's say, the VTY connectivity with our access class. Now, the VTY doesn't exist on a specific interface. In fact, it's in the center of the iOS config. So you can come in for access via VTY in any interface. Remember, we covered that in an earlier nugget. Now, what if somebody out here on this end of your network is able to spoof that address, 192.168.1.254, as a source address? So this guy is trying to seem like he is .254. What is in place to stop him? Well, with anti-spoofing, we would put an access list on this interface. Let's label them. Let's say this is E0 and this is E1. With anti-spoofing, we would place on interface E1 an access list that said, let's deny, access list number 1, let's deny 192.168.1.0, and then obviously we would put in the wildcard bits that match that statement. And this says that anybody from this network trying to gain entry into this interface here with a source address of 192.168.1 is going to be denied. And we're going to permit anybody else from coming in. So you can see how that would stop this individual machine from coming in and pretending like it's N1. All right, well, the same holds true on the other interface. We have E0 here. If we wanted to, we could say that we would deny the network 192.168.2.0, again with the wildcards in place, and then allow or permit anybody else. Same effect there. If a device on the inside tried to pretend like it was from the 192.168.2 network, it would be denied right here at this interface. Let's save ourselves some time on the router. And the reason we're doing that is we type in these commands exactly as you see them here, and then we use the IP access group command to apply that ACL to the individual interfaces, and we've accomplished our anti-spoofing. The next section that we have is removing the fluff from our routers, which is a general category that simply is saying if there's any service that is not used at all on your router, then don't have it on. This concept is easy enough when we're talking about the more well-known protocols. In other words, if you're turning on IGRP, it's not in use, you know that you need to turn it off. If IPX is enabled and you quit using it, you know that you need to turn it off because these are protocols that you configure yourself. Now let's talk about some of the more hidden protocols that might be running without you knowing. The first one is the small servers category. We have one for TCP and we have one for UDP. You'll recall from an earlier nugget that the TCP small servers include the echo, which echoes every character that you type, character generator that obviously generates characters, discard, and datetime, which is the date and the time. The UDP small servers is the echo, the discard, and the character generator. These small services are hardly used. Now, the reason I include them here is because version 11.3 and before, they're on by default. Okay, version 12.0 and after, they're off by default. So be aware of the version that you're running on your router, and if it is 11.3 or sooner, go in and turn these off. And you simply turn them off with the no service TCP-small-servers command or the no service UDP-small-servers command. Again, these protocols, if running and not in use, present a potential entry point for a hacker. Any protocol that's running that would be true of. It's a potential entry point or denial of service point for a hacker. Now on to our next protocol of concern, and that's the finger protocol. What it's going to do when it's issued is it's going to show you a list of users that are logged into your router at any given time. Although this list in itself doesn't seem too sensitive, it is going to be sensitive in the fact that it is a hint or a clue that can be given to the hackers so that they can know what IP address they need to spoof to gain access into these devices. So we want to turn this off. And as with the commands above, it is a service. So the no service finger command is going to turn that off. I'm going to issue the command no services and then the question mark to show you the entire list that's available there. So config terminal no service question mark, and it's going to show you a long list. Here you see finger at the top, and then as we continue you'll see TCP small servers, and if I go ahead and advance this, you're going to see UDP small service as well. So these are the commands that you would use, no service and then no specific protocols to turn it off. The last protocol that I've defined as fluff that we're going to cover is CDP. Remember, this is the Cisco Discovery Protocol. Operates at layer 2 and hands out a lot of information between Cisco devices that are directly connected. So if I have 3 routers directly connected into a network, they're going to share the CDP information. In most instances, this is a good thing. But if for some reason you don't need this on or you're not utilizing it, please turn it off, because somebody else can introduce a device. It would mirror itself as being a Cisco router, and it would collect a lot of information on each of these directly connected devices to include, again, information that could be hacked. Now this is the key. Whenever you want to turn CDP off, there's 2 ways of doing it. One is at a global level, so it would be CDP run. Obviously we'd have the no form of this command, so no CDP run. This is global. And then if you want to turn it off on a per interface basis, you can type in the no CDP enable, and this is on a specific interface, because you may have a case where this router has an environment here that's not as trusted, so you don't want CDP running out of these interfaces, but over here it's completely trusted and you want to share this with the rest of your local area network. Just recall the differences in the 2 commands. In our last section of this nugget, we're going to take a quick look at what is known as the PSIRT, and it stands for Product Security Incident Response Team. This is a Cisco team, and it's available on the Cisco website at www.cisco.com/work/public/707/advisory.html. Now what are you going to get out of this site? It's going to show you different sections. One, it's going to say if you're experiencing an attack right now, look here. So any attack, and it's going to give you guidelines and things that you could be doing as you experience the attack. It's also going to give you posted security advisories. This is probably the most important part. It's going to let you know what problems they know of with their switches and their routers and what you should do about it, the recommended fix actions. In some cases, it'll be a patch. In other cases, there's going to be a workaround until they can develop a patch. Another section they have in there is responses to BugTrack vulnerability notifications. BugTrack is a group that collects vulnerability notifications or security risk for all types of equipment, and they post them. Well, when they post some that are specific to Cisco, Cisco is going to respond in this section. And the response may say, here's the patch or the workaround, as we talked about up here, or it may even say, you know what, we don't believe this to be true. We couldn't prove it in our lab, so we think that it's not happening. That kind of a response. All right, and the last thing they're going to have is, if you want to report an individual vulnerability that you found in the Cisco, this is where you would do it. In this nugget, we started with a look at our password procedures. We talked about how the fact that we want each of our passwords, the user exec and the privilege exec, to be different. The service password encryption can be used so that we encrypt the passwords within the configuration, although that encryption is weak. So the enable secret over the enable password should be used because it has a strong encryption using MD5. And then, if you ever share your configuration files, use the show tech support command to send that out because it removes the passwords. We followed that with a look at the network management, specifically the SNMP protocol. And we talked about the fact that version 1 passed its community strings in clear text, and version 2 actually encrypted those community strings so it was better and allowed some filtering. True of both versions was the fact that it sets its community strings to default. In other words, public and private for the read and the read-write functionality, so you need to change those. Then we took a look at the login banner and understood that it should always be used in a production environment device and that it should never contain sensitive information. In trying to secure our VTY connections or our virtual terminals, we saw that protocol filtering could be accomplished by using the transport input command and address filtering by using the IP access class command to activate an access list. We also saw a session timeout that said if you don't pass traffic for N amount of seconds, we're going to disconnect you. From there we moved in to the console connections. We demonstrated how to set our console connection password different from any other passwords, including the VTY password. And then we talked about physical security and why it was so important because password recovery procedures could be accomplished via the console. When we moved into the HTTP server, we said turn it off. If you can't turn it off, though, we can use a secret port with the IP HTTP port command, and we can also filter addresses by using the IP HTTP access class command. We followed that with a discussion on anti-spoofing and saw that really all we need is access control lists applied at the right interfaces to make this happen. Then we moved into removing the fluff from our routers. We talked about turning off TCP small servers, UDP small servers, Finger, and the CDP protocol. And then we ended up with a talk on the PCERT, its function, and how you can look for the latest vulnerabilities there and report new ones as well. I hope this has been informative for you, and I'd like to thank you for viewing.